We take navigation for granted these days. GPS receivers guide airplanes, cars, and even cell phones. But did you know that the global positioning system is basically a big clock in space? There are 30 GPS satellites in orbit, and they just broadcast where they are and what time it is. All your phone GPS has to do is receive signals from 4 satellites, and it can triangulate its location in the 4 dimensions in which we live: 3 space and 1 time. But actually, it's not that simple. In order for navigation to work, the satellites carry atomic clocks accurate to the nanosecond. Otherwise, your GPS receiver might tell you you're halfway across town when you're still in the driveway. And special relativity tells us that moving clocks run slow, while general relativity tells us that clocks run faster higher in a gravitational field. These effects don't quite cancel. General relativity wins out, and time indeed runs faster up in orbit with the satellites. But some of the engineers working on the first GPS satellite couldn't bring themselves to believe that their clock would actually run fast just from being higher up, so they sent it up uncorrected. Within minutes, it was off by enough to impair GPS navigation, and by the end of the day, GPS receivers would have been wrong by tens of kilometers. Needless to say, the engineers turned the correction back on, and these days, they trust general relativity. Oh, and one last thing. GPS is also a nuclear weapons detector. There are always at least 4 GPS satellites visible from any point on Earth, and because of this, any nuclear detonation will be seen by enough satellites to pinpoint exactly where and when it took place.